Alrighty, in this video we're going to take a look at absolute value inequalities. I don't know where this fits in the book, but hey, whatever, goes where it goes. Just kind of go with the flow. It's in my notes like this. There's two things you got to remember for absolute value inequalities. They're very similar to the equations, as in you need to isolate first. So remember, isolate your absolute value first. Okay. Be careful if you have like a negative number, like a -2 in front. You're going to have to divide by a negative, and that rule of flipping the inequality will still apply. Okay, be careful. It's one of the biggest things that we mess up. Okay, and then it gets us to the actual question: is what type of inequality we have? We have less than or greater than. Okay, the way to remember it is if you're less than gives you two less, written as between this. Less between this. In other words, when you have a less than, you're going to write it between two things, between itself and its opposite. So taking a look at the example here, we have the absolute value already isolated. It's less than 2. So between this, because it's less. So then you take away your absolute value and you have less than. But then you're going to squeeze it between -2. I sometimes will use the word squeeze between. Okay, less thans are squeezes. Okay. Greater is harder because it's plus or less than minus. Right? Greater is an or. It's one or the other. Okay. What's going to happen with this one? If you have the absolute value of x greater than 2, it's going to be itself, greater. It's going to be greater than 2, or it's going to be less than its opposite, so less than -2. There's no bars put underneath when I talk about opposite. It's just the opposite of the number left. Okay. Sometimes there may be a little bit more stuff so you're gonna have to solve. Okay, but you should be okay. Okay. You can always check too. Okay. Think about it. This is all the numbers between -2 and 2, not including it. So if we did it in, it'd be -2 to 2. Would be how we would write it with brackets and parenthesis notation. Okay. Let's say pick a number. Pick 0. Is 0 less than 2? Yeah. However, if we looked at this one, we tried 0. 0 is greater than 2. That's no. This is not the way it's going to be. Okay, it's got to be greater than 2 or less than -2. If we take a look at the graphs, this is between these two things. Okay. On the other hand, this is the outside. It's the wings. Greater or two parts. One or the other. Okay, so -2. Yeah, that's almost a 3. There's a 2-ish. Okay. Notice how it's the opposite piece. Okay. Okay. And there you go. So you can see we're going to have a little bit of difficulty with these. But let's remember, isolate your absolute value. Then if it's less than, it's squeezed. If it's greater than, it's two things. Okay. Let's go to the examples in our notes and see how we do. Like I said, take your time. Always check. Make sure it makes sense. If it's in that shaded region, check it. You got nothing to lose outside of time. And trust me, you don't have, too many things to do, hopefully. Yeah, it's the beginning of the year. Maybe at the end of the year you got stuff to do, okay? But right now, check it. Yeah, do it for me, okay? Let's just begin with the first one. Okay. The absolute value of x is less than 4. It's already isolated, so it's squeezed between -4 and 4. Okay. If we put it in standard notation, it's -4 to 4. It doesn't include them, so it's parentheses. If I graphed it, -4, 4. Okay, open circles, no bar, no fill, and then it's in between. Less thans are betweens. Okay. Always try and get your absolute value also on the left side. Makes it so much easier. Sometimes you can make some mistakes if you have it on the right side. So just try not to do that, okay? Just get the absolute value always on the left. Add 3 to both of these sides to isolate. You get the absolute value of x is less than or equal to 5. Okay? So we're at that point. Now it's, because it's less than, it's squeezed between 5 and -5. Okay? So -5, 5. It's got bars, so we fill. And it's there in between. Okay? And this one would be -5 to 5 using brackets because straight lines equal them. All right, moving on to this one. We have this. Now this is going to become a compound sentence. This is where it gets cool. So you're going to have the same thing. It's already isolated. It's less than 1 and also less than -1. All right, what you do to 1, you do to all of them now. So you want to get on alone, you got to subtract 7. Well, you subtract 7 from all of them. Right? -8 is less than n, which is less than -6. Okay? So, if you look, boom, -8, -6, no bar, no fill, so in between there, okay, and, oops, no bar, no fill, so parentheses, -8 to 6. All right? Now, if you want to take this sentence apart, this is actually telling it move it 7 units to the left, and then we want to be 1 unit away from 7, or -7 units to the left. That's -7. You go 1 up from it, that's -6, and then, oops, I forgot the -6. Then 1 lower, it's -8. So it does deal with distances. Absolute values, you're going to see the distance away from the point. And we're going to use that, especially in calculus, delta epsilons, and things like that. Let's take a look at our final one here. Okay, it's got multiple steps in it, but already our absolute value is solved for, at least isolated. Okay, so put it between less than, squeeze, 6 and -6. I like these. You're going to see the other ones, you're going to have to do 2-steppers. So after that, add 2 to it all. 4 is less than or equal to 4x, which is less than or equal to 8. Divide it all now by 4, because you want to get x just to be 1x. 1 is less than x, which is less than dose 2. Okay? So at that point, all I have to do is graph it if we needed to. 1, 2. Don't forget your equals too. Just hit an equal sign. Fill it in because they're equal, and they're squeezed between it. Okay. And it's 1 and 2, and it's brackets because we're equal. Okay. So we're all good there. Questions there? Hopefully none. Let's move along to the other one. Greater, or, split. So, okay. Remember the split so from 7-Eleven? Probably not. That was something for me as a kid. It was 2 flavors of Sleepy's in one. All right. So you always keep 1 the same. X is greater than or equal to 3. And you always do the opposite. It's less than or equal to -3. Now, if we just take a look at that statement, you have to be all the things greater. So you're one or the other. It's the or. So if I'm just x is greater than 3, I can equal 3, and I got to be greater. So that's this one right here. Or I'm -3 or lower, less than it. So I can be this one, including 3. Okay. Notice how it's not the region in between. Less thans are squeezed, greaters are the outside. Or. Okay. Let's keep a look at this one. We're going to, again, get the absolute value of low. So we have both sides before we do anything. So the absolute value of x is greater than 4. Okay. At that point, let's just take a look. Splitso itself, x is greater than 4, x is less than -4. It's probably a good idea if we switch the order of them, because the left one, if you get the positive there and the negative there, makes it better. Okay. Now be careful, there could be like more numbers. If there was a 2 in front of it, like 2x, you would divide by 2, or watch out, if there's a negative, you could flip it. Okay, which would, then you'd have to say, oh, you gotta be one or the other. I always check those when we start playing with this. All right. So at this point, we get this. So we get -4, no bar, no fill, it's the outsides. Here, I'll show you in black to be a little more blue, I guess I'm going to go with those colors. All right, let's describe this in set notation so we can see it. I didn't do it in the last one. X is greater than 4. You're 4, and you're greater. You gotta go to infinity. You can never equal infinity. In this case, I can't equal 4. That's this set right here. Well, then let's take a look at this set. Less than 4. -4. So -4 is the biggest number, and it goes to -infinity. And then you put them together, union. Over here, let's take a look. This set is from 3 to infinity. It can never equal infinity, but it can equal 3 here. This set is from -infinity to -3. Does that make sense? Here's -infinity here. That's -3. Can equal it, so it's a bracket. never equal infinity, or go up to infinity, and get down. All right, cool, doing great. Take a look at this one. Notice the absolute value is already isolated. So we get n plus 2 is greater than 5, or n plus 2 is less than negative 5. Subtract 2 from both of them. N is greater than 3, or n is less than negative 7. Okay. If you're greater than 3, you go from 3 to infinity, and I cannot equal it. And then this one here is from negative infinity to negative 7. Can't equal it. You're going to take a look at the sets. Here's 3 to infinity. Ooh. And then negative 7 to negative infinity. Can't equal it there. All right. Let's take a look at our final one. Rooms. Nice view here. And I'll say, hey, you over there. Yoink. Bye-bye. Move. It's gotta go. Whatever. You have to just greater, isolated, separate. 2x minus 1 is greater than or equal to 8, or 2x minus 1 is less than negative 8. Add 1 to all of them. So I have 2x is greater than or equal to 9, and 2x is less than or equal to 7, and it's negative. Divide by 2 in it all. Keep it alone. Notice how if this was a negative, it would flip this sign, and then we'd be in our other situation. Right overlap. All right. After that, x is greater than or equal to, that's 4.5, just so you know. And over here, this is negative 3.5. Okay. Just taking a look at it. Negative 3.5 is easier to see. Open circle, it's closed. It's got a buffer fill. Okay, and then 4.5 over here. Fiddle that away. And those are the situations, okay? Again, if we were to try something, just try 0 in this. You probably 0. Is 0 minus 1, that's negative 1, the absolute value, negative 1 is 1. Is 0, or is 1 greater than or equal to 8? No. This shouldn't be in there anyway, so that's good. Check them out. You got time, like I said, do it. Okay? Make sure you get them right, okay? And you should be good with that, all right? They can get harder, and especially next year when you take pre-calc, you're going to do even more complicated things. We'll take a look at quadratics later on, but we're moving towards the next stuff, and it should be a review, but keep doing your thing, okay? And I'll see you later.